If 2 by 2 matrix 2x plus y 4x 5x minus 7 4x is equal to 7 7y minus 13 y x plus 6, then the value of x plus y is, so we know that two matrices are said to be equal when their orders are same and the corresponding elements are equal. So here two matrices with order 2 by 2, 2 by 2 matrix order is same. So we can equate the corresponding elements. So that is 2x plus y is equal to 7, 4x is equal to 7y minus 13, 5x minus 7 is equal to y, and 4x is equal to x plus 6. So the last equation is containing only one single variable. So we can simplify here 4x minus x is equal to 6. That is 3x is equal to 6, x is equal to 2. So let us substitute x is equal to 2 in any one of the equation. So let us substitute here 5 into 2 minus 7 is equal to y. That is 10 minus 7 is y. So y is equal to 3. So x is equal to 2 and y is equal to 3. Let us verify these two values satisfying any one of the equation. Let us substitute in this. 4 into 2 is equal to 7 into 3 minus 13. So 8 is equal to 21 minus 13. So 8 is equal to 8 is satisfying here. And even if we can check here 2 into 2 plus 3, that is 4 plus 3 7 is equal to 7 satisfying. So therefore we can conclude that x is equal to 2, y is equal to 3. So x plus y is equal to 5. So we can go with an option C. The sum of cofactors of 7 and 10 in the determinant 1, 2, 4, 5, 7, 8, 9, 10 and 12. So cofactor of 7, so we can say this is an element with second row second column. So we can write cofactor of 7 is equal to, that is a 2 2, which is minus 1 to the power of 2 plus 2 into minor of the element m22, that is minus 1 to the power 4 is plus 1, 1 into minor of the element, this minor of this element is determinant of 1, 4, 9, 12. So which is equal to 12 ones are 12 minus 9 fours are 36. So we can write minus 24. So cofactor of 7 is minus 24. Now let us find cofactor of 10. Cofactor of 10 is equal to 10 is element third row second column, that is a32. So we can write a32, which is minus 1 to the power of 3 plus 2 into minor of the element m32. So we can write minus 1 to the power 5 is minus 1 into m32. We can use deleting this row and column. So we have the determinant of 1, 4, 5, 8, which is equal to minus 1 into 8 ones are 8 minus 5 fours are 20. So that is 8 minus 20 is minus 12. So minus of minus 12, which is plus 12. And now the sum of cofactors. Sum of cofactors of 7 and 10 is equal to minus 24 plus 12, which is minus 12. So minus 12 is the answer. We can go with an option B. If A is equal to a matrix, a 3 by 3 matrix, 1, K, 3, 3K minus 2, 2, 3 minus 4 is singular matrix. then K is equal to. We can say that A is a singular matrix. A matrix is said to be singular if determinant is 0. If determinant of a matrix A is 0. Since it is given singular matrix, so we can write det A is equal to 0. That is determinant of 1, K, 3, 3K minus 2, 2, 3 minus 4, which is equal to 0. So you can write 1 times of minus 4K plus 6 minus K times of minus 12 plus 4 plus 3 times of 9 minus 2K is equal to 0. On simplifying, minus 4K plus 6 plus 12K minus 4K and again plus 9 threes are 27 minus 6K is equal to 0. So minus 4K plus 12K 8K, 8K minus 4K is 4K, 4K minus 6K is minus 2K, and the remaining 6 plus 27 is 33. So plus 33 is equal to 0, or we can write 2K is equal to 33. So K value is 33 upon 2. So to make this matrix a singular matrix, so the value of K must be equal to 33 upon 2, which is option C. If A is a square matrix of order 3 and det A is equal to 15, then find the determinant of adjoint of A. Determinant of adjoint of the matrix A is equal to, we know that det A to the power of n minus 1, where n is the order of matrix. Order of matrix A. So here n is equal to 3. It is given matrix order is 3. So we can write det A is nothing but 15. 15 to the power of 3 minus 1, that is 15 square. 15 square is 225. So we can write the determinant of adjoint of A is 225, which is option D. If determinant of a matrix A is equal to 3 and A inverse is given, a matrix 3 minus 1 minus 5 by 3, 2 by 3, then find the adjoint of a matrix A. We know that A inverse is equal to 1 by det A into adjoint of matrix A. So which implies adjoint of matrix A is equal to A inverse into det A. So we can write adjoint of A is equal to det A into A inverse. So that is determinant of A matrix is 3 into A inverse is 3 minus 1 minus 5 by 3, 2 by 3. So let us multiply scalar multiplication here. 3 into 3, 9. 3 into minus 1 minus 3. So 3 into minus 5 by 3 is minus 5. And 3 into 2 by 3 is 2. So adjoint of a matrix, we got it 9 minus 3 minus 5, 2, which is option B. If root x plus root y is equal to A, then find the value of dy by dx. So differentiating with respect to x, we have 1 by 2 root x plus 1 by 2 root y into dy by dx is equal to differentiation of root a is which is constant 0. Or we can write 1 by 2 root y dy by dx is equal to minus 1 by 2 root x. Since we know the dy by dx of root x is 1 by 2 root x. So now dy by dx is equal to minus 1 by 2 root x into 2 root y. So dy by dx is equal to 2 gets cancelled here, and we have minus root of y by x. So negative root of y by x is the answer, which is option C. The function f of x is equal to 1 plus x when x is less than or equals to 2 and 5 minus x when x is greater than 2 is continuous or differentiable. We need to check. So for continuity, left hand limit must be equal to right hand limit and it should be equal to the functional value at a point x is equal to a. So here at x is equal to 2, left hand limit is equal to limit extends to 2 minus f of x is equal to limit extends to 2. We have to consider 1 plus x function because it is below 2. So 1 plus 2 is 3. Similarly, right hand limit is equal to limit extends to 2 plus f of x. We need to consider above 2 function, that is limit extends to 2 5 minus x which is equal to 5 minus 2 which is 3. So we can say left hand limit, right hand limit both are same, and also f of 2 value where it is equal, x is equal to 2 is 1 plus x, so we can add 1 plus 2 which is 3. So we can consider that left hand limit, right hand limit and functional value all are equal. Left hand limit, right hand limit and the functional value, all the three are equal, so we can say the given function is continuous. Therefore f is continuous at x is equal to 2. And now coming to the differentiability, left hand derivative we can see at x is equal to 2, d by dx of left hand derivative means below function below 2, so we need to consider 1 plus x. So differentiation of 1 plus x is 1, and right hand derivative at x is equal to 2, d by dx of above 2 we need to consider 5 minus x which is 5 minus 1, sorry 0 minus 1, that is negative 1. And here we can say that left hand derivative is not equals to right hand derivative, hence f is not differentiable. F is not differentiable at x is equal to 2. So the given function is continuous but not differentiable at x is equal to 2. So we can go with an option B. The minimum value of x square plus 250 upon x is. So let us consider f of x is equal to x square plus 250 divided by x. To get minimum or maximum, f dash of x is equal to 0. So let us differentiate. Differentiate with respect to 2x. So we have f dash of x is equal to 2x plus 250 into 1 upon x differentiation is minus 1 by x square. So we have 2x minus 250 divided by x square. Now consider f dash of x is equal to 0. So we have 2x minus 250 upon x square is equal to 0, or we can write 2x power 3 minus 250 divided by x square is 0, and the denominator cannot be equal to 0. So we can consider 2x power 3 minus 250 is 0, or 2x power 3 is equal to 250, or x power 3 is equal to 125. That is x power 3 is equal to 125 is 5 cube, so x is equal to 5. Now to verify that whether at x is equal to 5 will get minimum or maximum, so we need to perform the double derivative. Since f dash of x is equal to 2x minus 250 divided by x square, now f double dash of x again differentiating, so we'll get 2 minus 250 times of, here we'll get minus 2 by x power 3, so that is 2 plus 500 divided by x power 3. So clearly we can say here f double dash of 5 will be positive because it is positive only. 2 plus 500 upon 5 cube will give positive value. Since f double dash of 5 is positive, so we can say f has minimum value. F has minimum value at x is equal to 5. So let us substitute f of 5 in the function, that is 5 square plus 250 divided by 5, that is 25 plus 50, which is 75. So 75 is the minimum value for the given function. At x is equal to 5, we get the minimum value 75. So option D is the answer. If m and n are the order and degree of the differential equation, 3x into dy by dx whole power 3 minus d square y by dx square minus 8y is equal to sin y. So in this differential equation, we can see that the derivatives which are used here, one is dy by dx and the other one is d square y by dx square. So here we can see that the d square y by dx square is the highest order. So this is second order derivative. So in the given equation, second order derivative is used, and the exponent of the second order derivative, the exponent of this second order derivative is 1. So we can say the degree is 1. So if m is order, so m is equal to 2 here and n is the degree, so n is equal to 1, then m plus n value is 2 plus 1, which is equal to 3. So we can go with an option C. The general solution of the differential equation x into dy by dx is equal to y plus x times of tan of y by x. Let us divide with x on both the sides. So we can write dy by dx is equal to y upon x plus tan of y by x. Let y by x is equal to v, or y is equal to x into v. So we have dy by dx is equal to differentiating with respect to x into dv by dx plus v into dx by dx is 1. So let us substitute here. dy by dx can be written as x into dv by dx plus v is equal to v plus tan v. So we can cancel v and v on both the sides, and here x into dv by dx is equal to tan v, or we can also write 1 upon tan v dv is equal to 1 upon x dx. Now integrating on both the sides, integration of 1 upon tan is cot v dv is equal to integration of 1 upon x dx. Integration of cot is log mod of sin x. So log mod of sin x is equal to log x. Integration of 1 upon x is log x plus some constant is log c. So that we can write log of mod sin x is equal to, or sin v, sorry, log of mod sin v is nothing but replacing back y by x is equal to log a plus log b is log x into c. Now removing logarithm on both the sides, so we can simplify and write here sin y by x is equal to x into c, or cx is equal to sin of y by x is the general solution for the given differential equation. So we can go with an option A. Projection of the vector 2i plus 3j plus 2k on the vector I plus 2j plus k is. We know that projection of a vector A on the vector or on the vector B is given by A dot B divided by mod B. So here let us consider, let A vector is equal to 2i plus 3j plus 2k and vector B is equal to I plus 2j plus k. So we have the projection of vector A on vector B is equal to A dot B divided by mod B, which is equal to 2i plus 3j plus 2k dot I plus 2j plus k divided by modulus of I plus 2j plus k, which is equal to 2 ones are 2 plus 3 twos are 6 plus 2 ones are 2 divided by root of 1 square plus 2 square plus 1 square, which is equal to 10 divided by root of 6. So 10 by root 6 is the answer, which is option A. If vector A, vector B and vector C are the unit vectors and A plus B plus C is equal to 0 vector, evaluate the quantity mu is equal to A dot B plus B dot C plus A dot C. Since A, B, C are unit vectors, so we can write mod A is equal to 1, mod of B is equal to 1, mod of C is equal to 1, and also it is given vector A plus vector B plus vector C is equal to 0 vector. Let us apply the dot product with A first. A dot of A plus B plus C is equal to A dot of 0. So we can write A dot A plus A dot B plus A dot C is equal to 0. A dot A is equal to mod A square. A dot A is nothing but mod A square we can write. And here mod A square plus A dot B plus A dot C is equal to 0. And we know mod A is equal to 1. So we can write 1 plus or 1 square plus A dot B plus A dot C is equal to 0, or A dot B plus A dot C is equal to minus 1. Similarly, when you do dot product with the B vector, so we can also write here B dot A plus B dot C is equal to minus 1. Similarly, we can say, and now, or this can also be written A dot B plus B dot C is equal to minus 1, since dot product is scalar. I mean A dot B is equal to B dot A. And now, similarly, now if we can multiply with the dot product with the C vector, so we'll be getting C dot A plus C dot B is equal to minus 1, since C dot C is equal to mod C square, which is 1. Or this can also be written A dot C plus B dot C is equal to negative 1. Now consider these three, say 1, this is 2, and say this is 3. Adding 1, 2 and 3, adding 1, 2 and 3, we get 2 times of A dot B, 2 times of B dot C plus 2 times of A dot C is equal to minus 3. Are 2 taken common. A dot B plus B dot C plus A dot C is equal to minus 3. Or we can write A dot B plus B dot C plus C dot A is equal to minus 3 by 2. So the answer is minus 3 by 2, which is option D. Two adjacent sides of the parallelogram are given by the vectors. A vector is equal to 3i plus j plus 4k and B vector is equal to I minus j plus k. Then the area of the parallelogram is given by mod of A cross B. The vector area is A cross B and the area of the parallelogram is mod of A cross B. So let us find A cross B here. A cross B is equal to determinant of I, j, k. The vector A is 3, 1, 4. Vector B is 1, minus 1 and 1, which is equal to I times of 1 plus 4, 5, minus j times of 3 minus 4 minus 1 plus k times of minus 3 minus 1 is minus 4. So which is equal to 5i plus j minus 4k, and mod of A cross B is equal to the root of 5 square plus 1 square minus 4 whole square, which is equal to root of 25 plus 1 plus 16. So we can write here 42. So root of 42 square units is the answer. So which is option A. So we can go with an option A. The Cartesian equation of the line joining the points 3 comma minus 2 comma minus 5 and 3 comma minus 2 comma 6. The points are here x1, y1, z1, x2, y2 and z2. So we know that the equation of the line passing through these 2 points is x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. This is 2-point form of a line. So we can substitute here. Therefore, required equation, that is Cartesian equation of a line joining 2 points A and B is given by x minus x1, that is x minus 3 upon x2 minus x1, that is 3 minus 3, y minus of minus 2 upon minus 2 minus of minus 2, and z minus of minus 5 upon 6 minus of minus 5, which is x minus 3 upon 0 is equal to y plus 2 upon 0 is equal to z plus 5 upon 11. So the equation of the line is x minus 3 upon 0, y plus 2 upon 0, z plus 5 upon 11, which is option B. If I plus 3j plus 8k vector cross product with 3i minus kj plus mk is equal to 0 vector, then what is the value of k and m? So cross product, let us write I, j, k, and the first vector components are given 1, 3, 8, and the second vector components are given 3, minus k and m, and the cross product is given as 0. So let us simplify this. We can write I times of 3m plus 8k minus j times of 1 times m minus 8 3 is a 24 plus k times of minus k minus 9 is equal to 0. 0 vector can also be written 0i plus 0j plus 0k. The components of 0 vector are 0 0 0. So comparing both the sides, so we can say 3m plus 8k is equal to 0 and m minus 24 is equal to 0 and minus k minus 9 is equal to 0. So let us write here m minus 24, m minus 24 or negative of m minus 24 is equal to 0 or m minus 24 is equal to 0. So m is equal to 24, and coming to the next one, minus k minus 9 is equal to 0 or minus k is equal to 9. So k is equal to minus 9. And let us also verify the first one, 3 times of m plus 8 times of minus 9, that is 60 plus 12, 72 minus 72, which gives 0. It is satisfying. So we can confirm that the value of m is 24 and the value of k is minus 9, which is option A. The optimal value of the objective function is attained at the points on x-axis or corner points of the feasible region or y-axis in the first quadrant. And we know that for any profit function, z is equal to ax plus by with respect to certain constraints, linear inequalities. The optimal value, that is maximum or minimum value, will be obtained at the point of intersection of all the linear inequalities lines, or we can say the corner points, obtained at the corner points of the feasible region obtained by the constraints. So we can say that the option B is the right answer. The feasible region corresponding to the linear constraints of a linear programming problem is given below. Which of the following is not a constraint to the given LPP, linear programming problem? So here the diagram is given. You can see that first one line equation, x plus y is equal to 2. By substituting origin 0 plus 0 is 0, is the inequality is towards away from the origin, means it is the other side. We can say that 0 should not satisfy, which means we can say that x plus y should be greater than 2 or equals to 2. So the solution inequality for this problem can be considered as x plus y is greater than or equals to 2, which is the first option. So it is the constant of the given LPP. And coming to the second one, x plus 2y is equal to 10. Let us substitute origin 0 plus 0, which is 0. 0 should be less than 10 to satisfy that the solution is towards the origin. So 0 must satisfy here, origin must satisfy. So 0 less than or equals to 10. So we can consider that x plus 2y is less than or equals to 10 must be the linear constraint. So which is the second option. So second option is also constraint. And coming to the next line, x minus y is equal to 1. So we can say x minus y is equal to 1 here. Substituting the origin, and here we can say that the shaded region will be towards the origin, so it must satisfy 0 minus 0 is 0, less than or equals to 1. That is x minus 5 should be less than or equals to 1 is the must be the constant to satisfy the origin. But here the third option, x minus y is less than greater than or equals to 1, which is quite opposite, so we can say that this is not a constant. And fourth one, it is a constant, x minus y less than or equals to 1 is a constant. So which of the following is not a constant, so you can give the option as C. Option C is the answer. If A and B are two independent events with P of A is equal to 3 by 5 and P of B is equal to 4 by 9, then find P of A bar intersection B bar, which can also be written P of A union B whole bar by De Morgan's law, which is 1 minus P of A union B. And since the two events A and B are two independent events, so P of A intersection B is equal to P of A into P of B, which is 3 upon 5 into 4 upon 9, which is 12 divided by, or 3 times here, so 4 by 15. So we can write 4 by 15 P of A intersection B. Now P of A union B is equal to P of A union B is equal to P of A plus P of B minus P of A intersection B, which is equal to 3 upon 5 plus 4 upon 9 minus 4 upon 15. So here we can consider, so 9 3 is a 27 plus 20 upon 45 minus 4 3 is a 12 upon 45. That is 27 plus 20, or 27 plus 8, 35 upon 45 we can simplify. That is 5 7 times 5, 9 times 7 upon 9. And P of A bar intersection B bar is equal to 1 minus P of A union B, that is 1 minus 7 upon 9, that is 9 minus 7, 2 upon 9. So 2 upon 9 will be the answer for this question, which is option B. Assertion and reason based question. Assertion given, sine inverse of sine 2 pi by 3 is equal to 2 pi by 3, and the reasoning is given, sine inverse of sine theta is equal to theta if theta belongs to minus pi by 2 to plus pi by 2. So this is correct statement. Sine inverse of sine theta is equal to theta when theta is belongs to the principal value prime, that is minus pi by 2 to plus pi by 2. But here in the assertion, sine inverse of sine 2 pi by 3 cannot be equal to 2 pi by 3, since 2 pi by 3 value is 120 degrees, which is not belonging to the range, minus pi by 2 to plus pi by 2. So we can say that the assertion is false and the reason is true. So we can go with an option, assertion is false or reason is true, which is option D. Assertion reason based questions. Assertion given, if integral 0 to 1 3x square plus 2x plus k dx is equal to 0, then the value of k is minus 2. Let us simplify this. Integration of 3x square is 3 into x power 3 by 3 plus 2 into x power 2 divided by 2 plus k into x over the limits 0 to 1, which is 0. So here we can write x power 3 plus x square plus kx over the limits 0 to 1, which is 0. On simplifying, 1 cube plus 1 square
plus k into 1, the upper limit, minus the lower limit is 0 plus k into 0, which is equal to 0. So we can write 1 plus 1 2, 2 plus k minus 0 is equal to 0, or k is equal to minus 2. So the value of k is minus 2, which is correct. So the first assertion is correct. And obviously integral a to b x power n dx is equal to x power n plus 1 by n plus 1 plus c. It's an indefinite integration, but here it is a definite integral. So this is not the correct answer. So integral a to b x power n dx is equal to x power n plus 1 by n plus 1, applying the limits, lower limit and upper limit. After applying, you will get a constant. So there is no integral constant for this. So reason is false and assertion is true. So assertion is true and reason is false, which is option C. Option C is the answer.